Hello, my student. The topic for this video is to review set of real numbers and inequality symbol less than, greater than, less than or equal, greater than or equal. Let's begin with the set of real numbers. Given this set of numbers, we are going to find out which one of the elements inside this set of number belong to the set of natural number. Again, the set of natural number begin with 1 and it increase by 1. So the first thing we should do, we have to go back to our given set of number and then simplify if we can. So let me go ahead and highlight the number that we can simplify. So let's say here 0 divided by 3 could be equal 0. And then 12 divided by 4 will be equal 3. And square root of negative 4 is a complex number or imaginary number. So we are not going to talk about this number. It doesn't belong to the set of real number. You are going to learn about this set of number in college. So let's begin with the set of natural numbers. So we know that the smallest number in the set of natural number is 1 and it increased by 1, so we can see it by here 10. So 10, I'm going to divide by here 10, and then keep going. We don't have 0 in the set of natural number. We have a 3, and that's it. Now let's go to the set of whole numbers. The set of whole number is bigger than the set of natural number by 1 number. So basically the set of natural numbers is the subset of the set of whole number by 0. Okay, so we have 0, and when we copy this, I can put the smaller number first, so 3, 10. Next, let's go to the set of integer. So the set of whole number is a subset of the set of integers. So all of these 3 numbers inside the set of whole number will belong to the set of integer plus the negative. So we have negative 9. We cannot take negative 4 over 7 because it is a rational number. It is a fraction. We don't take it. So we have 0, 3, and 10. Okay, let's go to rational numbers. The set of integers is a subset of rational numbers. So all 4 numbers belong to the set of integer will be inside this. Will be element of the set of rational numbers plus the fraction. Okay. So I have negative 9, 0, 3, 10. So I'm just copy this. I'm just transfer this 4 elements from the set of integer to the set of rational numbers. Now I'm going to go back and look for more fraction. So I have 7 over 3, and then now if you see a bar on top of your decimal places, it tells you that this decimal places will be repeat. So if you have a number with decimal places repeat, you can write them in fractions. So I'm going to tell that number in the set of rational number 4.56 repeat the decimal place. And then this number, even it is a decimal number, but you can see that all the decimal places doesn't repeat. Okay, so we cannot list this number to the set of rational numbers. So we skip this number. The 0 is only here. The pi is an irrational number because we cannot write pi as a fraction, but we have -4/7. And then the 3 we have here, so that's it. So let's move on to the set of irrational number. But this decimal with non-repeat decimal places, when you put them in the set of irrational number, 5.73, 773, 7773, 7777, etc. And we have pi. So there are two numbers belong to the set of irrational number. Now let's move on to the set of real numbers. The set of real numbers is the biggest set that you learn right now. Okay, so the set of rational number is a subset of the set of real number, and irrational number is also a subset of the set of real numbers. So therefore, I'm going to write out all the elements belong to the set of rational number here to the set of real number, and also plus the two elements or the two numbers of the set of irrational number. So basically you copy everything, right? So negative 0, 3, 10, 7/2, 4.56, negative 4/7, and 5.773. Okay, I think I don't have enough space to write this, so I am going to write the pi first, and then come on to the next one. I'm going to write 5.73, 773, 7773, 7777, etc. So now let's move on to example 2. In example 2, you are going to use the symbol less than, greater than, less than or equal, and greater than or equal. So let's start with the first part A. 2 is less than 5. Why? We can look at the number line. 2, the coordinate 2 lies to the left of the coordinate 5 on the real number line. So that's why 2 is less than 5. Let's move on to part B. Part B, -1 is greater than -3. Why? So let's go back to the real number line. -1 lies to the right of -3. So therefore, -1 is greater than -3 on the real number line. Let's move on to part C. 3.5 is less than or equal 7/2. Basically, 7 divided by 2 is also 3.5. So when you have less than or equal, it means that either one of the tests must be true. So in this case, will be 3.5 equals 7/2. So now let's go ahead and go to the left hand side and write down question. I'm going to model one question, and then you will create your second question here. Okay? Is it possible that 0 is less than or equal to 0? Now let's write down the summary. So our summary, based on my observation right here, I'm to write the direction of the inequality symbols always point to the smaller number. For example, 2 is less than 3, so the direction, which is where the point right, the vertex right here, is point to the smaller number. Or 2 is greater than 1, so again the direction is always point to the smaller number. This will be the conclusion of this video. I see you in class. Goodbye, my student.